Well, welcome to Adam. So now we have to solve this question, which is based on a 15 V-MU diagram. There we have been given that A is a hill support and at D there is a roller support and D is an overhanging B. So between this is nothing but an overhanging B, where there is a certain force which is 20 Newton at D. Also there is an inclined force is B. So that is how like the beam is subjected to load, and we need to find the SFD and VMD for the following B. We also have a UD between CD. So let us see how we can do this. Firstly, we know that we need to make the FBD to find the support reactions. The second thing which you need to do is finding the shear forces and bending moments at every point. So let us see how we can solve for step 1. We need to draw the FBD, which will be something like this. We have A, we have B, we have C, D, and let us say there is something like this E. At A we have yield support, so we will give forces in both the directions, so FAY and FAX. At B there is a inclined load, so we will convert that into horizontal and vertical components, which will be something like this: 200 sine 30, and this will be 200 cos 30. Between C and D there is a UDL, so we will convert that into a point load, which will be 40 into 3 120, acting at the midpoint of CD, which is nothing but 1.5 from C and 1.5 from D meters. And between D there is a roller support, so at D we will apply, let us say, FTY. At E we have a 20 Newton downward force, which is a sudden force. So let us see how we can draw the FBD. Calculate for the reactions. We have between A to B we have a distance of 1.5 meters. So let us just write the distances first. We have 1.5. BTC also we have a 2 meters, and D to E we have a 2.5. Yeah. So we have a horizontal equilibrium, which is a summation of fx is 0. For that we have fax minus 200 cos 30 is 0. So fax comes out to be 200 cos 30. And secondly, we have a summation of fy is 0, which is the vertical forces equilibrium. We have fay plus fdy minus 200 sin 30 because of the UDL, because of the sudden force at B. And we have minus 120 because of the UDL, minus 20 because of the sudden force at E. So we have fay plus fdy is equal to 100, because 200 sin 30 is 1 by 2. So it will become 100 plus 120 plus 20, which will be 240. Equation number 1, let us say. And you cannot solve this equation because you have two variables and only one equation. So we need another equation which we will get by moment condition, which is moment at any point in an beam which is in equilibrium is A. So let us calculate moment at A, because fay will disappear and we will only have dy in our equation. We have 200 sin 30 into 1.5. It is a clockwise movement because of this force at point B, so we will take it as positive. And we also have a 120, like the force 120, because of which the movement again will be clockwise. The 120 force is because of this UDL. So we have 1.5 plus 1.5, this total distance, which is between A to this UDL force. The total distance becomes 3 plus 2, 5. So we have plus 5 into 120. And we also have a FDY, which is acting upward, so it will be an anti-clockwise movement, so we'll be writing negative for that. And the total distance which we have is 5 plus 1.5, which is 6.5. Yeah. And we also have 20 Newton force acting at E, but in the clockwise direction, so again it will be positive. 20 into 6.5 plus 2.5 will give you 9. Yeah, 9. So the total beam length will become 9. So let us see how we can calculate FDY from this. We have 100 again into 1.5 plus 120 into 5 plus 20 into 9 divided by 6.5, 143. So FDY comes out to be 143. And if you put this into your equation number 1, you will get FAY as 240 minus 143. So 240 minus 143 comes out to be 97. So it will be 97. So let us just cross check your answer once by solving this equation again. We have 100, 230 is 100 into 1.5 plus 120 into 5 plus 20 into 9 divided by 6.5. Yeah, you have 143 as your answer. So let us just write the forces which we have found here, which is we have AY as a 97. We have FD1 as a 143. So yeah, let us just move on to the step 2, which was calculating the suggested this. Yeah, this should be 5 as the total distance. Yeah, the step 2 was calculating the shear forces at every point. So let us try to calculate shear forces at every point to make the shear force diagram. So for the step 2, starting we have a shear force at point A, which will be the reaction at point A, which will be 97. And we also have a shear force just left of B. So whenever there is a certain force, just at B there is a certain force of 200, which is inclined force. So you need to calculate the shear force at left and at right of the certain point. So let us say at E also there is a certain force, and at D also there is a like reaction force. So you need to calculate at left and right of that forces, because they will suddenly jump values at that particular point. So you need to have an idea of how it is varying at that particular point. So it is like suggested to calculate shear force just left of B and just right of B whenever there is a sudden force at particular point. So we have shear force just left of B as 97 only, because there is no, so again this sign convention for shear force, so we will just quickly go through it. Sign convention for shear force, we have, whenever you are calculating forces on the left, you need to consider upward as positive and downward as negative. And whenever you are considering forces on the right, you need to consider upward as negative and downward as positive. So this is the sign convention for the shear force 1. And we have shear forces, mostly we'll calculate on the left of the beam. So just remember the upward one, which is upward forces are positive and downward forces are negative. So that is why we are saying that shear force just left of B is 97, because there is no shear force between A and B. As you can see in the diagram, there is a certain force at B only. So it will be the same between A and B. So shear force just left of B will be just right the same what it was at right of A, which was 97. So shear force just the right of B will be 97 minus 200 sine 30. Why this is minus? Because again we are considering forces on the left. So let us see across the beam somewhere here just right of V, and here this force 200 sine 30, and it is on the left. So negative force, sorry, downward forces will be negative. Mostly we will be calculating on the left only, so forces from the left only. So just remember this left sign convention. So we have 97 minus 100, we have minus 3. Shear force at C will be nothing but shear, which it was just right of B, which is minus 3, because there is no force between B and C. And after C it will vary linearly, because there is radian, and it will go to something at D. So let us see what it goes to. We have shear force at left of D, because again there is a certain force at T, which is the reaction at D. So we need to calculate left and right of D. So we have minus 3 minus 40 into 3, which is 120 because of the UDL. And we have this as minus 123. And the shear force at the right of D, we have minus 123 and plus 143. because there is a sudden reaction force of 143 at point T. So if you are just crossing the beam somewhere here, right of T, you need to consider this forces also. Because we are considering force on the left. So it will be 20. With shear force, just left of E, just left of E will be the same, which is 20. And shear force at E, or you can say at right of E, it will be 0 because there will be a 20 and there is a certain force of minus 20 acting there. So it will be 0 at point E. So we have shear forces at every point. So let us just draw the shear force diagram. We have A, we have B, we have C, we have D, we have E. At D we have a shear force of 97, so it will be 97. At B we have left of B we have shear force of 97, right of B we have a shear force of minus 3, so it will be minus 3, we have 97. At C we have minus 3, left of D we have minus 123, so minus 123. Right of D we have 20, so it will be something as 20. And left of B we have 20 and at E we have 0. So there is something at 97 and it will not change until B. It will suddenly jump at B, which will go to just right of B, it will go to minus 3. And between B to C, there is some, at C it is minus 3. Okay, yeah, at C it is a minus 3 only, so it will not change. And between C and D there is a union, so it will vary linearly until minus 123. Where just right of D it is 20, positive 20, so it will suddenly jump because of the reaction force at D. And then it will remain constant until it goes to 0. So this is how you can draw your shear force diagram for the particular problem. So yeah, let us move ahead to calculate the bending moment diagram, which we can calculate just calculating the bending moment at every point 2. The same thing we will follow, that whenever there is a sudden movement, we will calculate just left of the point and just right of the point. But in our condition, or sorry, in our case, we do not have such point where there is a sudden movement acting at a certain point. So we will not take care of that. We just need to take care of like the sudden forces in this particular problem. So if there was a sudden movement acting somewhere, we need to consider left and right of that particular point. So sign convention for bending moment will be, if you are considering force on the left, you need to consider clockwise as positive, anti-clockwise as negative. And if you are considering force on the right, then you need to consider clockwise as negative and anti-clockwise as positive. Yeah. So contrary to the shear force case, if you are like, sometimes you will be considering on the right forces also. So try to like remember both of the sign convention, that for the bending moment only. So what we did in the shear force case is we always considered forces on the left side of the cross section. So we do not need to worry about the right side convention. But in this case, sometimes it will be easy for us to calculate the movement based on the right side forces. As you will see for when we go forward in this question. So the right side convention also becomes important for this particular problem or this particular bending moment case. So let's see how we can do that. We have moment at A. So bending moment at A and E is 0. Why is this 0? Because of the equilibrium condition. So equilibrium. You can cross check this, it will come out to be 0 because at the end points of the beam, unless there is a fixed support, the bending moment at the end of the beam will become 0. We have a bending moment at B. So yeah, if you consider forces on the left, which is only one force, 97 force because of the A, this is point B, this is point A, and the distance between them are 1.5. So the moment will become 97 into 1.5 in the clockwise direction, and the forces is on the left. So on the left, clockwise is positive. So it will be 97 into 1.5 positive. So 97 into 1.5, it will be 145.5. Bending moment at C. Like you can observe that we are not calculating left and right of any point. We are just calculating at particular point because there is no sudden moment acting here. We have at A 97. At B we have this 100 force acting downwards, 200 sin 30, which is 100. This is point C. This is point B. This is point A. We have a distance of 2 from B to C and a distance of 1.5 from A to B. Yeah. You can just like cross your beam somewhere here and check the left side forces of the draw the FBD for the left side forces. Just cross your beam somewhere here. Once you make the FBD, it will be easy for you to make the other another like cross sections FBD. So yeah, we have 97 into 3.5 because this is 2 plus 1.5 is 3.5 and it is in the clockwise direction, so we will take it as a positive minus there is 100 into 2 because it is in the anti-clockwise direction, so we will take it as negative. We have 97 into 3.5 minus 2 only 139.5. We also have bending moment at D. So yeah, now you can observe that let us see you are considering forces somewhere on the left. So there are too many forces, as you can see, 120 force, this force at B, this force at A. Instead of that, you can directly consider force on the right, which is just one force, which is the 20 Newton force acting at E. So it will be very easy to calculate moment at that point because there is a 20 Newton force and at E and the distance is 2.5. So we will directly can write that it is nothing but 120 into 2.5, but it is in the clockwise, so it will become negative now. Because if you are considering force on the right and it is clockwise, then it will be negative. So 120 into 2.5, we have 300 minus 300 at D. Sweet. Yeah. And at E, so bending moment at E, we have 0, which we have already calculated. So that's as now we have calculated the bending moment at every point. Let us try to make the bending moment diagram. We have this point A, point B, point C, point D, point E. At A we have a 0. At B we have 145.5, 145.5. At C we have 139.5. At C we have 139.5. At D we have minus 300. So minus 300. At E we have 0. And again, if the shear force is varying, like if the shear force is constant in the shear force diagram, then the bending moment will vary like an inclined line. And if the shear force is an inclined line, the bending moment will vary parabolically, 1 degree above the shear force. So A to B, we have a linear line. B to C also, it will slightly decrease to 139.5. And C to D, we have an UDL. So the force, the bending moment will vary parabolically. So 139 to minus 300 it is going. So we can directly write doing like same thing like this. This is a parabola. And it will vary linearly up to this. This is how you can draw the bending moment diagram for the particular question. Thank you.